In this video, we're going to talk about graphing linear inequalities. So remember, an inequality is a statement that compares two expressions, but it uses this, 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 or this. In other words, less than, greater than, less than or equal to, or greater than or equal to. Very important concept number one. Graphs of linear inequalities, you must always shade part of the graph. Because, remember, it doesn't just equal something. It's got to have part of it shaded to represent the greater than, less than, the greater than, equal to, or less than or equal to. So instead of just drawing a line, like when we graphed equations, we're also going to shade in part of it. Very important concept number two. To graph linear inequalities, ignore the inequality sign and graph just like you did linear equations. In other words, get the line on there. But then the inequality sign is going to determine if the line is dotted, or solid. If you have just a greater than or less than sign, you're going to do a dotted line. So, like this. If it's a less than or equal to or greater than or equal to sign, it's going to be solid, just like it was when we did linear equations. Okay, so let's graph one. So if we're going to graph the inequality, y is greater than 2x plus 1, this is a dotted line because it's just a greater than symbol. We're going to graph it like it reads y equals 2x plus 1. So remember, plot your b and then go up 2 over 1. So plotted my positive 1 and then I went up 2 over 1. And I kept repeating it. Now it is a dotted line, so as you can see, I've dotted it. And now I have shaded all of this up here because y is greater than 2x plus 1. Since it's greater than, I've shaded in all of the area above 2x plus 1. Now yes, some of that does include negative, but it also includes all of this area above positive 1. Okay, so again, I made a dotted line because it was just a greater than sign, and then I shaded the area above the line. That's what differentiates this from just graphing an equation. So let's graph another one. So this time we have y is less than or equal to 3x plus 3. Remember, we want to graph it as 3x plus 5, as just like we would y equals 3x plus 5. So come here to our plus 5, then go up 3 over 1. This time it's a solid line because it was a less than or equal to, and because it's less than, this time my shading is on this side. So I want to include everything that's less than it. So when my sign faced that way, I shaded up here, but since it's open that way, this time I shade below. Okay, so one more thing to talk about with inequalities. How do we determine which ordered pairs are a solution to the inequality? So let's say we have 2, negative 3, and this is our inequality. So I'm going to plug in my x and y value where I see it. So I would have negative 3 is less than 2 minus 1. So that makes negative 3 is less than 1. Is negative 3 yet less than 1? Yes, it is. So we would say yes. The ordered pair 2, negative 3 is a solution to this inequality. In other words, when we shade it in, this ordered pair should be covered by our shading. What about this one? Is negative 2 less than negative 1 minus 1? Well, this comes out to be negative 2. It's negative 2 less than negative 2. No, they're equal. So this would not. This should fall, well, it's a dashed line, but this should fall on that dashed line, not in your shading. Okay, what about here? Negative 1 is less than 3 minus 1. Is negative 1 less than 2? Yes. So this ordered pair would also fall into your shading. So to find out if an ordered pair is a solution to an inequality, you simply plug in your x and y values to the inequalities, x and y. Even if there is an m value here, you can still just put it in and then multiply. And that's how you deal with inequalities and graphing them.